Alright, this is your 7.5 video, and we are talking about indirect measurement. And that's exactly what it sounds like. It's any method that uses formulas, similar figures, and or proportions to measure an object. So direct measurement would be to get out your ruler, to get out your yardstick and actually measure it. But sometimes that's not feasible. So we use this indirect measurement where we use math to still get the measurement without actually getting out a ruler. Okay, and you've used this a lot, you just didn't call it indirect measurement. So here we go. Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow, and then he made the diagram. What is the height of the pole? So we talked about on Monday, or in 7.1, that it didn't matter if one figure was in centimeters and one was in feet. That didn't change my proportion. But what is not okay is if the one figure is in mixed units like this one is, 7 feet 8 inches, 5 feet 9 inches. They have to be all in one unit before you can get started. Now, I can tell that I'm going for the telephone pole here, so this is going to be a large distance, a large height, so I want to keep mine in feet rather than change it to inches. It's really a matter of personal preference. If you wanted to change yours to inches, that'd be fine. I like to keep mine in feet since I know my final answer is going to be in feet. So I am going to go and change all of these. You know there's 12 inches in a foot, so 9 divided by 12 would be 3/4. So I'm going to change this to 5.75. 8 divided by 12, this one would be 7.67 feet. It might even be better to keep it 7.667 feet. An extra decimal never hurt anybody. And then 4 divided by 12 is 1/3, so this one would be 3.833 feet. Okay, like I said, if you wanted to change this to inches and you wanted to say that is 60, so this would be 69 inches and on, that would be okay too. I'm just going to leave mine like this. So then, once I get this all changed over, now it's just a regular proportion. 5.75 over 7.667 is equal to x over 38.333. Okay, so then I can cross multiply. 220.415, and then divide that off. So this is 28.749. Now, so this is the height of the pole is 28.749 feet, but I need to change this back over into mixed units. So I know that it's going to be 28 feet. All I have to figure out is how many inches is this. So I'm just going to do 0.749 times 12. 0.749 times 12, and I get 8.988. So I'm just going to call that 9 inches. So 28 feet, 9 inches. Okay, so on this one, the actual converting the units all into feet and then back into mixed feet and units is actually more difficult than the proportion you've been doing for a long time. So make sure you take care with that and you don't try to go too fast. Alright, a scale drawing represents an object smaller than or larger than its actual size. So you know about these architects, people who design cars and things like that. You don't want to work with your actual dimensions, so you make a scale that's smaller than. And the scale's drawing is the ratio of any length in the drawing to the actual length. So they're basically giving you the scale factor, just like we learned about in 7.2, and we're working from there. So on a Wisconsin road map, Kristen measures the distance as 11 1/8 inch from Madison to Wausau. The scale of this map is 1 inch is 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? Okay, so I do have this fraction in here, and they're telling me I'm going to answer in the nearest mile, so I can go ahead and change that over to a decimal if you feel more comfortable that way. So 1/8 is actually 0.125, so I'm going to say 11.125 inches. Now, one thing that I like to do is I like to keep my units when I'm doing a scale factor, just to make sure I'm lining this up properly inches with inches, miles with miles. So I put my 11.125 across from my 1 inch on my scale. My 13 miles, of course, goes on the bottom, and that is what I'm after right there. Your scale factor is always going to be one half of the ratio by itself, and then your actual distance that you're measuring is going to be the other half. You just have to make sure that your units line up, that you don't flip this over. If you don't, then there's no way you can mess this up. Okay, so when I cross multiply, I actually get 1x is equal to 144.625, and then I can round. It says to the nearest mile, so that would be 145 miles would be my final answer. Okay, then I could go back and double check and make sure that makes sense, but it does to me. 1 inch is 13 miles, then this should be substantially larger, so 145 there. Okay, y'all pause and try the second one. All right, now this one you have to do twice because we have one scale, 1 centimeter to 3/4 of a meter, but I'm doing this for the length of the tablet and for the width of the tablet, so I have to do this problem twice. So here's my scale, equal to, I did the 7.19 first, cross multiplied and got 9.59. Then I did still my scale over here. The only thing I substituted out was now I put in the width of the tablet, and so then I cross multiplied and divided, and here is my answer of the model dimensions right there. Okay, this last concept is one that always shows up on the EOC, it always shows up on the tax, and it is a little bit confusing just because there's so many different ways about it. So we're going to go pretty slow here. Take your time, rewatch this segment if you need to. We're going to talk about what happens if I change dimensions, if I change the length or change the width, what happens when I talk about perimeter, what happens when I talk about area, and what happens when I talk about volume. So let's review perimeter, area, and volume. Perimeter, you know, is just adding up all of the sides. And when I do that, I keep the regular unit. So if my problem is in inches, my answer is in inches. If my problem is in feet, my answer is in feet. Okay? Then area, you are multiplying two of the dimensions. So length times width. Or base times height, whatever the figure may be. When I do that, I end up with square units. So meters squared, feet squared. Because if you have like a rectangle that's 3 by 5, then for perimeter you just add all of these up. I just did that drawing way off scale, didn't I? So this would be, the perimeter would be 16 meters. But when I go to do area, I multiply 3 meters times 5 meters, so I end up getting 15 meters squared. So perimeter is regular units, area is units squared. Volume, if I were to turn this into a rectangular prism, I would have 3 dimensions now, length, width, and the height of the figure over here. Now, ignore this thing. So I would have length, width, and height. That is really, really ugly. Anyway, so then I would multiply all 3 dimensions together, length times width times height. So then I would be in cubic units, centimeters cubed, inches cubed, meters cubed. Okay, so knowing all that, this chart is really going to be what is going to help you out here. Okay, so let's start with perimeter. If I change one dimension, and I'm going to do all of these with an example, and let's say our example is a rectangle that's 2 by 3. So let's say I just am going to double one side. So my new one is 4 by 3. So let's look at our perimeter. This is 3, this is 2, 6, 7, 8, 9, 10. So this one has a perimeter of 10. 8 and 6, this one has a perimeter of 14. Is there any special relationship between 10 and 14? Is it double? Is it triple? Is it anything like that? No, it is not. So when I change one dimension of a perimeter, there is no effect. Now, I don't mean nothing happened. Obviously, if I doubled this one, then it's going to get bigger, but there's no special relationship is what I'm looking for. So I think you probably have room to put this. I made these boxes bigger than I did last year. So you actually have room to put that in there. There is no effect going on here. It's not double, it's not triple, it's not anything like that. Okay, let's move on down. Let's keep with perimeter. Now let's see what happens if I change 2 of the dimensions. So I still am going to have my 2, why do I keep doing that where I draw it backward? My 2 by 3. Now I'm going to double both dimensions. So when I redraw this, now instead of 3, I'm going to have 6. Instead of 2, I'm going to have 4. So I still have my original perimeter of 10, but my new perimeter is going to be 20. Let's call these inches. So look what happened when I doubled both the dimensions, my perimeter doubled. Double both dimensions, the perimeter doubled. So the change, we're going to use delta for change, the change in perimeter is equal to the change in your dimensions. And this is always going to be true. If I tell you triple the dimensions, then you're going to triple the area. If I tell you to half the dimensions, then you're perimeter rather, not area. If I tell you to triple the dimensions, you're going to triple the perimeter. If I tell you to half the dimensions, then you're going to half the perimeter. So here's what a problem like this would say. I would say you have a rectangle that is 15 by 8. What is the perimeter if you triple the dimensions? So you already know, you can already do the perimeter of this one right here. I can say 15 times 2 plus 8 times 2. And I already know that the perimeter I'm currently working with is 46. So instead of going through and tripling, and then recalculating, I can just say, well, I know if this perimeter is, then all I have to do is triple that. So the new one is going to be 138. And that saves you a lot of work. Okay, let's move on to area. Obviously, we can't change 3 dimensions in perimeter or area because it doesn't have one. So that's why I blocked out that one. We only need the change in 3 dimensions for area. Okay, so let's look at what happens when I change 1 dimension. So we're going to keep with this 2 by 3 box here. So we'll still pretend like we're working in inches. So the area here would be 6 inches squared. When I double 1 dimension, my new area is 12 inches squared. So what happened? I doubled the area. So the change in the area is equal to the change in when I change 1 dimension. So if I tripled the length, I'm going to triple the area. If I halved the width, I'm going to half the area. Which is kind of different from here because on this one I had to change both dimensions in order to get that change. But for area, since I'm multiplying, I only have to change one or the other. Okay, so for instance, if I told you I have a triangle with an area of 42. And I am going to half the width. Then, without even knowing the actual dimensions of the triangle originally, I can say, well, if you're going to half one of the dimensions, then I'm going to half the area. And the new area will be 21 feet squared, whatever it is. So if I'm changing 1 dimension, I only have to half the 1 time. Okay. Now let's look at what happens when I change both dimensions. So I'm going to redraw my diagram. So I'm still going to double this to be 6 inches. Now I'm going to double this to be 4 inches. So now the result is 24 inches squared. So let's write what I did. I doubled 2 dimensions. and I quadrupled the area. What this is, the change in the area is equal to the change in the dimensions squared. Because basically what you did is you did times 2 to the length times 2 to the width. So times 2 would be times 4. Okay, I know that's a little bit confusing, and we'll go over this more in class because I know this is a confusing concept, but the more you see it now and you write it down, the easier it'll be. So if I told you that I was going to quadruple the dimensions, then that would mean my scale factor would be 3. So I'm going to square that scale factor, and the area would multiply by 9. So if I'm changing it 3 by the length, 3 by the width, 3 times 3 is 9. So the area is 9 times as large. Okay. All right, let's look at volume. Now you get to see my awesome volume drawings, and you get a peek of what's coming in chapter 9 and 10. Okay, so we are going to have a rectangular prism that is 2 inches by 3 inches by 4 inches. I think it's just easier if you use different dimensions or different lengths for all the sides. Okay, so the volume for this is going to be 24 inches cubed for our regular one. I did 2 times 3 is 6, 6 times 4 is 12. So let's keep with our theme, and let's double one dimension. So let's change this to be 4 by 3. I'm going to make these boxes big enough again this year. So now I doubled the length, so I went from 2 to 4, but I kept the other ones the same, 3 inches and 4 inches. So what I have now, 4 times 3 is 12, 12 times 4 is 48 inches cubed. So I double the volume. So the change in the volume is equal to the change in one dimension. I doubled the length, I doubled the volume. I triple the width, I triple the volume. I half the height, then I'm going to half the volume. It's the same as it was for area. Perimeter's really the odd man out here. Okay, let's move on to 2 dimensions, and let's try this again. Get to see another pretty picture. So this is still 2 by 3 by 4. So this still has a volume of 24 cubic inches. So this time let's double the length and the width. So we'll call this 4 inches by 6 inches, and this will still remain 4 inches. So now what we have, when we were to calculate the volume, we would do 4 length times width times height, 4 times 6 times 4. And now we have a volume of 96 inches cubed. So I doubled the length and the width, and by doing that, I quadrupled the volume. So the change in the volume is equal to the change in the dimensions squared. Same as it was over here, because I made the change twice. I doubled the length, I doubled the width, so that ends up being quadrupling both of those. Oh, Keller's up from his nap. Okay, last one. This time we're going to change all 3 dimensions. So I'm still going to start out with my 2 by 3 by 4 inch rectangular prism. So I'm still going to start out with a volume of 24 inches cubed. Now I'm going to double all 3 of the dimensions. So now I'm going to have a 4 by 6 by 8. 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So I'm going to double all 3 of the dimensions. So what comes out is I now have a volume of 192 inches cubed. So in this case, I doubled the length, the width, and the height, and therefore I made the volume go up times 8. Because what I did is think of this as times 2 times 2 times 2. So 2 cubed is 8 because I multiplied it once for each dimension, times 2 times 2 times 2. So the change in the volume is equal to the change in the dimension cubed. Okay, so this is an example where we're going to use this chart. So you have to be careful since there are 7 different topics that they could do. Change this, change this. Here we have 7 different options. You have to be very careful you're doing the right one. So it says, given that triangle LMN is similar to QRT, find the perimeter of the area of QRS. So they don't give me all the dimensions, so it's not like I can just say, who cares? I'll just do the problem. I'll double them all, triple them all, whatever happens. So all they give me is the perimeter of the area and then 2 of the sides so I can find the scale factor here. So let's start by doing that. 13 divided by 9.1. That means my scale factor, or how much I'm changing the dimensions by, is 1. No, I did that backwards. Let's do 9.1 over 13. And we're going to get this to be 0.7. Now, that's a common problem, and here's how I knew that I didn't want that. What I got on the first one was 1.43. But if I multiply by 1.43, I'm going to say this figure is going to be getting bigger, and it's not. It should be getting smaller. So it was my fault. I should have put the small one on top and the big one on bottom so that I get a scale factor that's less than 1, so that all my other answers are going to be getting smaller. If I had used this 1.43 when I did perimeter, I would have gotten something like 45. Well, this obviously doesn't have a perimeter of 45. It needs to have a smaller number. So that's where I knew I needed to flip the sign over. Now, on this particular problem, we're changing all the dimensions at the same time. I'm not doing this where I just change one or the other. I'm actually going to be doing these 2 boxes where I change them both. So let's see what happened here. If I wanted whatever change in the perimeter was how much I changed the dimensions by. So I can just keep this very simple. I can take the perimeter that they gave me, multiply it by my scale factor, and there is my answer. This one is going to have a perimeter of 25.2. It should be getting smaller, and it should be getting smaller proportionally at the same time. So I just need to reduce that. Now, same concept, except for when I go to change the area, I have to remember that I have to square this scale factor because I'm going to be doing it once for the base and once for the height of the triangle. So you take your original area, you take your scale factor, but because it's area and I'm doing it twice, length times width or base times height or whatever it might be, I have to do the scale factor squared. So then I'm going to do that. 60 times 0.7 squared. 29.4 inches squared is going to be my... Oh, why did I make up that these were in inches? How about centimeters squared? It's going to be my area. Okay, so this one is an easy one because we're not changing one dimension at a time, we're changing all the dimensions. So all you have to remember is for perimeter, you keep it regular. For area, you square it. If they had asked me volume, I would have cubed it, but this is a 2-dimensional figure. Okay, see you tomorrow.